I'm Falk. I'm from Darmstadt. I'm also part of the Java community. I'm one of the organizers of Java User Group Darmstadt, where we have the next event tomorrow. So if you are still hungry for knowledge and are in the Rhine-Main area, then please come to us. And there's another quite nice initiative. It's called Cyberland. It's a lot of online events. For example, we have monthly open source code camps where you can dive into open source software development if you're interested in. Okay, let's go to the topic, Java, the value objects in Java. And we already heard about in the keynote that the Java release cadence changed to half-year releases. So there are few projects, so-called incubator projects, in which in Java a lot of new features get developed. For example, there's Project Amber, which we know because of pattern matching. A lot of new features, and with some smaller syntax improvements like local variable type inference and all that stuff around the easy main method, for example. Then there's Project Project Panama with the vector API and foreign function memory API. There's Project Loom with, for example, the virtual threads, and there's Project Leiden to improve startup time to peak, improve the time to peak performance and minimize memory footprint. There are some more projects, but these are, I think, the most interesting. And of course, there is a project which where the value objects, value classes gets developed already since about 10 or 11 years now. It's called Valhalla. Where does the name come from? It's from the Nordic mythology. Valhalla means Hall of the Fallen Warriors, and I asked ChatGPT what that's have to do with the value objects in Java, and he said it could be a wordplay, a play of words. Val for values, and Valhalla means Hall of Values, but I don't know if it is correct, so maybe it's just a hallucination. Okay, let's go into it. What is Project Valhalla? When you go to the project page, then they tell us that they want to combine the abstraction of object-oriented programming, which we need to define custom data types, for example, with the performance characteristics of the simple primitive types like int and boolean and so on. Or in other words, you can also say it should code like a class, but works like an int. And Brian Goetz, one of the language architects at Oracle, calls it the Java's epic refactor because it's quite a deep cut through different layers, through the user model, through the language, through the Java virtual machine. So it's quite complicated. Already told you that since 10 or 11 years, they already started to implement this new feature, but it's still ongoing. And I still don't know when it will get released. I hope maybe this year, next year, I don't know. So we come to that back in a few minutes. So when you go to the project page, they already list a few features they already have been implemented in Java 11, Java 12, Java 15, Java 16. The first one is JEP 181. JEP stands for JDK Enhancement Proposal. It's kind of a specification. It's called Nest-Based Access Control, and it has to do with the access on private members between different classes. So they have a new concept, nestmates, and it's a bit easier to create composite objects that are not actually reference objects, which the normal objects. Then the second one is JEP 309. It's called Dynamic Class File Constants. So they have a new bytecode mechanism. It's called Constant Dynamic. And they want to have kind of a lazy initialization of some constants when they have to be calculated first time when they are used. So it's not that they have to be calculated on the start of the application, for example. The third one is JAP 3.3.4. It's called JVM Constants API. So they also started a new API for type-safe programming with constants in the Java bytecode. And all of them are quite of fundamentals for value objects. The fourth one is hidden classes, about hidden classes. So they want to create at runtime classes which should not be referenced by regular classes. And they need them for inline the value objects. We will talk about it in a few minutes. And the last one, it's about warnings for value-based classes. It's JAP 3.9.0. Value-based classes, we already have a view of them in the JVM, in the JDK, in the Java Development Kit. It's actually a design pattern, which means that they should be immutable, they have no identity, that should not be synchronized, and should actually, they can't, but they should be compared via equals equals. And we get some warnings if we use them in the wrong, if we have the wrong behavior, and they try to require to correct usage of the behavior of value-based classes. So quite a few JAPs already implemented. So let's go, what's the problem? Why do we need value objects at all? And so I want to show you some examples. What are the problems between primitive types and object references, the normal objects in Java? So it's kind of a legacy of the Java memory model. Let's start with the primitive types. We all know them. There is, for example, these variable I. It's an integer 1, 2, 3, 4, 5, and actually it's stored on the stack. The stack is the place where my statements which the program executes are stored, and all the method handles are there, and also local variables, for example. Actually, I don't know what I means. So what is the meaning of I? Maybe it's a zip code, and I should have a better naming. I should not use I as a variable name. I should use zip code, for example. But it's still kind of not type safe, because we call it primitive obsession. Primitive obsession is a concept of refactoring code smells. Maybe you've heard about code smells in the context of refactoring. There's a very good book of Martin Fowler. And primitive obsession means that we always use primitive types. That doesn't not only mean primitive types in Java. That could also be built-in types like string, for example, like date. They are still primitive types for me, because a date could be a birthday, a string could be an email, and email and birthday would be better types, for example. And of course, most of the time we don't use zip code as one field here or something like that. We often use it inside objects. For example, we can have a record address, and one of the members of this record is a zip code. That would be easy, but it's still primitive obsession. It's still an int. And we get into some trouble if we have multiple int members, for example, the house number in this address and the zip code. And then we just, when we create a new instance of address, then we can easily mix it up and just swap accidentally the both values, and that could be still a problem, I think. So that was a quite easy example, and let's go a bit deeper. We already saw there's the primitive types, the object references. The primitive types are actually stored on the stack, and there's another place in the JVM where information are stored. It's called heap. Heap is a bit more expensive most of the time, because the stack is actually a bit closer to the CPU where the calculations run, and as if the memory which has to be accessed from the CPU is far more away, then it's more expensive to get the values. There are multiple caches involved, and if I don't find the value in the caches, then I always have a cache miss, and that costs a bit of performance. And I have another example, or a few examples, where I want to show you how much memory is used in Java by object references, by primitive types. And actually, GenAI, for example, ChatGPT helped me to determine these values, these numbers. And a friend of mine, he's also here, he had already a talk this morning, Johannes Bechberger, he helped me a bit to correct the value, so many thanks to that. And let's start with a very simple example. We have just int variable I with the value 42. It's only 4 bytes, so that's quite easy and quite small. So let's take an object. I have a record point with 2 member fields, x and y, and I have a new instance with 2 values, 1 and 1. How much memory does that use? And there we have on the stack still the reference to this point, but the actual point is on the heap, is saved, is stored on the heap. And it has some overhead. It has, of course, both the values, both ones, and it has a header. And let's have a look how much space that needs. So the reference is actually 4 bytes if it's compressed, or 8 bytes. I don't know it does depend on the used JVM. So maybe 4 or 8 bytes. It can be compressed. And on the heap, we have a header for each object, which uses 12 bytes. Then we have x and y with 4 bytes each, and we have a padding of 4 bytes. I will talk about padding in just a second. So there is a sum of 24 bytes. So actually, if we have only 2 int variables, then we have 8 bytes, but we have 3 times 24 bytes because of header of overhead. So what does padding mean? Padding is a mechanism where the memory is filled up to a multiple of 8 bytes because of modern processor architectures. And so if we have maybe 22 bytes, then it will get filled up with 2 more bytes. So we have 24, then it's a multiple by 8. So let's compare some different implementations. And I have a list of points. So let's say 10 points, 0, 0, 0, 1, 1, 0, and so on. And there are multiple possible implementations. A very efficient, but maybe difficult to read and to maintain is just, or actually there are just 2 int arrays for the x's and for the y's. And the other implementation could be an array of point objects. So I define a new data type, it's called point, with x and y, and then I have an array of that. So let's see how much memory will be consumed if I have 10 points, and we will start, of course, again with the first with the 2 arrays of ints, and there we have about, maybe, I'm not sure if it's right, so I asked ChatGPT and I asked some friends, so maybe if you have some more information about it, please come to me and we can correct the values. So we have 2 times a header of the int array. It's stored in the stack, and it's 12 byte each. And then we have, actually for each value in the array, we have 4 bytes. So 10 times 4 bytes, so it's 56 bytes with padding, and that 2 times, so it should be 112 bytes if I store it that way. And of course, it's not maintainable, and maintainability is quite a very important architecture goal for most of us. So let's try the second version. It's with a class point, with an object point. Could look like that way. I think you all know that. And let's see how much memory it will consume. We still have a reference of point array in our stack, which could be 4 or 8 bytes. And then on the heap, we have a header for the point array, for the array, which is 12 bytes. Then we still have the references inside the array, which are referencing the different points, which are separately on the heap. And we have information about the length of the array. So it's actually 56 bytes only for the array. And then we have 10 times 24 bytes for each point. So it's about 300 bytes. I'm not sure. Maybe there's still some little information missing, but it's about 300 bytes. So when we compare that, so it's a factor of 2, or actually a factor of 3. The two int arrays, which are not very good readable and maintainable, and the one point array, which is of course the better solution, but maybe not as a performant. So let's see what are the differences between primitive types and object references before we go to the value objects which are in between. So primitive types like the int, double, or boolean are stored directly in the stack. So they are kind of local variables. There is no indirection. They have quite a fast access. It's the concept of locality. So the processing of the memory is quite near, next to the CPU. So it's cache friendly. And we have a fixed size. We have no header. So the JVM can optimize, can inline, can do a lot of optimization because of the information that it's fixed and no dynamic structure. On the other side, the object references like strings, arrays, points, whatever, they are located on the heap, only the reference on the stack. The indirection, there's an indirection via the pointer, so the access is a bit slower, and there's still more overhead like the object header, which are beside the fields which we have to store, and the memory may be fragmented, so it's a bit more expensive to find all the informations of the different objects, of the parts of the object. And we still have garbage collection, which is also a quite nice feature in Java, but which maybe if you have 100 millions of points, which can be quite expensive. So let's see what are value objects all about. And I still are in my example of this comparison. And we already saw 2 versions. And now let's have a look at the third version. It's an array of point values. And actually, the implementation of a value object, of a value class, is very simple. You just have to add the value keyword before record or class. So record or class, you can use both. And actually, that's quite simple. So we have to talk about the consequences, but the implementation is already there. So I could also use value class, of course, but then I have to do some more boilerplate code to implement some more boilerplate code. So let's stay with records. I hope you all know records. They are in Java since Java 13, I think, and still final since 17. So records are just, actually it's a bit simplification from the compiler. We only have to declare which elements are in the record, and then we get some implementation of constructors, of final fields, of accessors, of toString and hash code. So it saves us a bit boilerplate code in that way. So we can use it here as a value record point. And how much memory will it consume? Actually, I don't know, because that depends on the JVM. But the JVM can optimize it. And if we still have our example, we have a primitive value int of 42. We have a reference point, which is quite a bit overhead in the heap. If we have an instance of this value object point, It can be inlined, they call it inline, on the stack, and it will only contain the two values for x and y and no header, no overhead. And then if we have two int values, then it's just 8 bytes actually. But I don't know, because depends on the JVM. It could also be on the heap, then without header, but still with a reference and with some more, a longer way between the CPU and the memory, for example. So what does it mean? What does value classes, value objects mean? They have no identity. That means when we compare two value objects, then they will be compared. The values of the value objects will be compared. So the fields are compared, like in equals equals or in hash code. They can't be used for synchronization, which we need for to tackle race conditions in parallel programming, but we don't need that much, so it can't be used there, and it's not allowed. And we already talked about it, JVM can optimize the memory layout and the performance, for example, by inlining the value objects on the stack and just save it where it's used and make a copy by value instead of copy by reference, for example. And the value class or value record can, like every normal class, also have some methods like move by here. And there are some restrictions, like it's not allowed to have subclasses of value objects, and you're not allowed to have a superclass, but you can implement interfaces, for example. And so most of the time they look like normal classes, so you can define your own data types, which is I think for me, I'm not a performance guy, not that deep into performance. I think it's more important for most of us, to have to define clear data types, like email address, like birthday, like different kind, instead of using the primitive or the built-in types, string, int, and so on. Yeah, let's come back to our example, and I asked ChatGPT, and the first two lines we already saw. The third line is the same example with value types. One point array and point is a value type. There we have about 96 bytes. It's actually a bit less than the two int arrays, because we only have one array, so less overhead here. And then we have an array list of point objects, which is a bit more overhead, because the array list needs some more memory. And then we still have another one, an array list of point values, and then that's also slightly more than point array, but it's also quite efficient. It's only 128 bytes. So what do we save with value objects? You already saw maybe some memory, for example, and you can save up to 50%, so you can have 50% less memory. And if you're interested how that works, and if you want to see some more examples, then please stay in this room after my talk. Kay Horstman will have a second talk about it, and will go deeper and show some more examples. And I saw his talk already. He was 3 or 4 weeks ago in Darmstadt at the Java user group, and it's quite interesting talk. So I can recommend, if you're interested in how that works, and he makes some more concrete examples and do also live coding, I think, then please stay here. So what are the other things we can save? It's a faster direct access, as the data is closer to the CPU, so better cache access. We already talked about that. And if I have values on the stack, they will get removed automatically, because the stack will cleaned up after the statements are executed. And there will no garbage collection, which is not a problem if we have only a few objects, but will get a problem if we have millions of objects, for example, value objects or normal objects. So that's it. that's value classes, but we still have some time. So what else do we have to talk about it? There are some more JAPs in the context of Project Valhalla. The first JAP, it's 401 value classes. I think that will be the first one we will see in the JDK, in the Open JDK. I still hope that we will see it in 25, which will be released in September this year, but I don't think that will work, so let's hope that we will see it in March next year, 26. By the way, now we have 2025 and Java 25. I would suggest that we stop the half-year releases and go to one-year releases, and then we can have the same Java version number than the year. But I think they won't listen to me. So there are some more JAPs. For example, there are two JAP drafts. One, they still don't have a JAP number, so maybe they will get 520 or whatever, I don't know. There are still drafts, so there is one JAP draft about so-called null-restricted types. We will have a look at it in a few seconds. There's still another one which is called null-restricted value types, which seems the same, but it's not. And there's already a JAP 402, which is called enhanced primitive boxing. And I think there will be a bit more JAPs coming later, which we don't know yet because it's more complicated than we think. So let's start with the JAP XX. I don't know what the number will be, but it's called null restricted types. And the first question is, can value type variables be null? And of course, they can't be null. So if I have a value class point, they can be null. Sorry, it was wrong way around. They can be null. The question is why, if they have a new kind of type, why do they allow a nullable? And the reason is it's because of downward compatibility. We still have in Java is famous because of we still can run Java code which is written 30 years ago, at least if it doesn't use applets and security manager, but if it's still normal Java code, we can still use it. And we, for example, have interfaces, and we have maybe a value class which implements the interface, and we have a normal object class which implements the interface, and we have a reference of interface. We don't know yet if it will be a value class or if it will a value object or not, and so he can't actually say it's not allowed to be null, for example. And they are not think about new concepts like copy by value, and they have to integrate these value types in the existing system, and it's already quite complicated. So we have to, if we want to restrict types to be null, then we have to explicitly declare not nullable types. And the goals of this JAP will be type safety to avoid null pointer exceptions. So we get information about null pointers already at compile time. And it will be explicit specification of null, like Kotlin already uses. Actually, Kotlin do it the other way around. The default in Kotlin is every reference is not allowed to be null. But we can say that this reference is allowed to have a null reference or is a null reference, but C# also have such kind of concepts. And we want to have some warnings if we convert, for example, like in generics, a raw type to a generic type or the other way around. And the compatibility, we want to ensure interoperability with existing Java code. So how does it look like? If we have a null restricted type, then we need a exclamation mark. I think it's in English, Ausrufezeichen in German, sorry for that. So point, and then P is allowed to have a new point reference, a value object in that case, and if I'm not allowed to have a null reference here. So, and if null is permitted, then the JVM, also if it's not an exclamation mark here, then the JVM must always reserve memory, because it has to know if it's null or not null, so you can't inline it, and flattening inlining is that not possible. And if I have the possibility to null restrict my references, then the JVM can really embed a list or an array of points or whatever, for example. And then if the optimization works, that depends on the JVM, but I think we will see some great improvements there in the next years after the value objects have been released, and then the performance and memory consumption can be massively improved. So we will have point exclamation mark, which means null is not allowed. We will have point question mark, which means this type or this reference can be null. And we still will have point without any mark, and that means no specification behavior as before, so the compatibility with older code. And maybe you have already recognized it. It's not only about value types here. So these null-restricted types will be for every object reference, for value object references and also for normal object references. So it's quite a big thing. So we can have such a kind of implementation than we have in Kotlin already, but the other way around. So default is not specified, and we can have null-restricted or especially null-allowed references. So let's go to the second chap draft, and it's called null-restricted value types. And this is only for value classes. It defines a new type that is guaranteed to not be null, and that allows the JVM to optimize, like the flattening, like null checks can be avoided, and some more active performance optimizations. And the implementation could look like, but this chap is quite in an early draft, so I think it won't be the final implementation. This keyword by value, underline by value, is kind of a strawman syntax, and it's not finalized yet. So when you have a look at all the different articles about value objects, there are quite a few blog posts and articles in the internet, then you will see they already had some different kinds of keywords instead of value, for example. They also use some other strawman syntax, and here I think underline by value won't be the final version. But if I have a point value object, then I can have these kind of keyword by value in that case, which means that these value object will always be not null. This reference will always be not null. Okay, let's go to the third one, which is called enhanced primitive boxing. It's chap 402. And there's a very good article. There are 3 parts of these articles, and the I'm not sure, the third one is it. It's about why we have generics. We have now what's the history about generics. Most of us know generics were introduced in Java 5, so it's 20 years ago. I don't know. It's quite a long time. So I think most of you started maybe later to work with Java, so they already they are fed up with generics. But we have some difficulties, some problems with generics all the time, especially because of so-called type erasure. And type erasure, that was a deliberate or that was a decision they took because of a balance between compatibility, simplicity, and the technical possibilities they had in that time 20 years ago. And now we have some more. There are some more possibilities, and I already told you they make a deep cut through all the layers of Java, and so they try to address these previous limitations. For example, what is not allowed at the moment, we can't have a list of ints, for example, of primitive types, but that's one of the goals, that we will have kind of a list or collection of primitive values. And actually, we can't rework the primitive values, or the primitive types, but we will have this type in between the value objects, which look like objects, but have the specification of primitive types. And that way, we will actually have kind of a list of int, for example. Yeah, so autoboxing is already there. We can autobox, or if we have an int primitive value and we need an integer wrapper object reference, then there will be kind of autoboxing. So it will be transferred between primitive and object types. And we will actually we only have these 8 classic wrapper classes, integer, double, short, Boolean, and so on, and we want to have some more possibilities to define our own data types, which also can be auto-boxed, for example. And actually then we will have kind of a list or optional, for example, of type value class or of type primitive. And a very early example, or an example of the early draft, is that we have a value class unsigned int here, and we have to annotate it with @primitiveBox. I don't know if that will be the final syntax, but maybe that's the best idea they have at the moment. But then we can say that there will be an auto-boxing between int and the unsigned int value class, which we have here. Okay. Let's come to the end. Some bits of summary. I will show you a bit some more references and further informations. Let's start. What and how are value types? And actually, they are final classes with immutable fields. They if I want to compare two instances of value objects, they will be compared by the state, by the content of this value objects, not by the identity. Identity is actually the reference to an address in the heap, and now we will always compare the content. Synchronization is not possible. We already talked about it, and the JVM can optimize, like flattening, like intern some informations at that place where it already uses it, and it don't have to resolute the references, for example. And it can also, JVM is quite famous for just inline, for example, methods, and in how we can also replace Scala values, for example. And there are already a few classes we all know, like integer, one of the wrapper classes of the 8 primitive types, or local date, or optional. They are they are examples of these value-based classes, of these pattern. And the idea is to get new implementations. So the new integer from Java 26, 27, whenever it will start, will be that integer, the current implementation will be a value class implementation, as well as local date as optional. Here's a table with all the informations, the comparison between, on the left-hand side, primitive types, value objects in the middle, and regular objects on the right-hand side. And you see the differences, like we have some limitations, for example, with constructors. Constructors in value objects means you are not allowed to reference this, while there is no this, or there will be maybe no this, because this is the object on the heap, and maybe it's inlined in somewhere in the stack, so there will be no this if the JVM optimizes it. And these are some restrictions, for example. Also with nullability, we already talked about it. Actually, every object, value objects, normal objects, can be null at the moment. The references can be null, but there will be some ideas how we can have null-restricted types, for example. Boxing will be quite interesting, so we can define our own auto-boxing mechanisms, not only for the primitive types int and boolean, also for points, for birthday, for email address, or maybe zip code if we have a data type zip code. And synchronization is a problem, but most of the time I think we don't have to handle it. And garbage collection is only used, of course, if the value objects are on the heap, and if they are optimized or they are inlined on the stack, then we don't need garbage collection and save some time because of the garbage collector, which stops the world maybe because of too many memory access. Yeah, why do we have to use them, or why do we want to use them? For me, it's about speaking data types, so we can define our own, more frequently own data types. We already can do that with records, because it's much more simpler to define a Java class now with records. But we still have the performance overhead. We talked about it in that session. So now we can have very performant, efficient objects. So we can define our own data types as objects, but they are also performant, and the memory model is optimized. So it will reduce the gap between the primitive types and the objects. So there will be auto-boxing also for self-defined or by our self-defined data types. And we can have kind of generic parameters also with primitive types, like a list of int. Actually, it will be a list of integer, but integer will not be an object anymore in the future. It will be a value object, which is actually just an int. So it's just the 4 byte of an int and not any header, any overhead anymore. And so we get better performance, less memory consumption, and actually we don't have to handle all of that, because the JVM will do, as already 30 years. JVM always gets faster from version to version. And for me, Java is now 30 years, and I think, and I hope you are the same opinion, the Java world and the whole ecosystem is more alive than ever. And like the virtual threads in Java 21, like Stream API and Lambda expressions in Java 8 and so on, we have a new big topic. It's called value objects. I hope it will start in maybe a few months, I don't know. So the question is, Valhalla when? It's kind of a running gag. On Java 1 I heard about it. Maybe the guys at Oracle can tell us a bit more about it. I haven't been at Java 1, so they always asked Valhalla when, and as always, Brian Goetz, when you ask when it will be released, the feature, he says he can't promise it's ready when it's ready, and maybe we have some people here on the conference we can ask about the current state. I'm not involved, so I'm just interested in this topic, and had a look at all the JABs and so on. So you can try it out. You don't have to install any version. There is a very, I think you all know the Java shell, the J shell, which you can start on your own computer, but you can also use it in the browser. There's one version on dev.java, I think. That's the Oracle, official Oracle page, web page about informations of the JDK. And there is this very interesting website. It's called Java Almanac. If you don't know it yet, you should definitely have a look, because it's just a comparison between the different Java versions. Very interesting, and it also have this virtual Valhalla sandbox where we can just try Java code with value class, value record, and so on. So please try it out. Kay Horstman, he is the speaker after me. I think he is participated in the implementation of this Java Almanac. Yeah, and you can also try it on your own, on your laptop, and it's quite easy to just build your own JDK. There are some pre-built pre-releases of Valhalla, but I think the last one is already 1 year old. But it's quite easy. I tried it by my own, and I've never tried to build a JDK. but it was the first time. It took about 30 minutes and it worked. Just have to clone the OpenJDK Valhalla GitHub repo and then just make a bash configure command and make images. And then it will build the release, the OpenJDK, and put it in kind of a subdirectory. And then if you use already SDKman, which I always recommend that you will use it, then you can switch between different Java versions, and then you can just install these locally built Valhalla OpenJDK release, and then you can just switch from your normal Java 21 release to maybe the Valhalla release. At the moment, I think there are not that many informations about value objects, except, of course, the JABs and some articles, but a very good resource is dev.java, and I think there will be some more informations about value objects soon. And there's insight.java, which gets some more deeper insights, so have a look at that. And if you are interested in the slides, I will, in a few minutes, upload them, and you can just scan the QR code and embark.de/download. Embark, the company where I work for. Embark is a consultancy. We do lots of consulting in software architecture, trainings, ISAQB. If you have any questions, please come to me. And I've also quite a tip. It's called Architekturspicker. It's about documentation as code. Actually, it's only there's only a German version, but English version is coming soon. And we have 15 of these cheat sheets, Spicker, and there are some already in English. So please have a look. And now, actually, time is over. So if you have some more questions, please come to me. Thanks for your attention and enjoy the rest of the conference.